This disclaimer will explain why I have been very careful about using trademarked brand names only for educational purposes and avoided using photographs that I didn't take. In a utopian world, making the blade travel perpendicular to the table surface would not be an issue because the bow that contains the pulleys that hold the blade would be manufactured to maintain an accurate relationship to the table base, so that when we are making a cut in the horizontal cutting mode of the saw will drop down on a perfectly perpendicular plane to the machined flat surface of the table base. However, manufacturing tolerances prevent that on some saws, and they cannot, as provided, make a square cut without shimming the stock, which is highly undesirable. One method to accomplish an adjustment of the vertical cutting plane is discussed in this video, Adjustments Part 3A. Depending upon the accuracy of your particular saw and what you use your saw for, you may choose to leave your saw at its as-purchased accuracy. Everything is a compromise on a saw that reaches its goal of having both a horizontal and a vertical cutting mode by twisting the blade at 2 points in the blade path around the pulleys. No saw, or any tool in fact, is perfect. It just depends upon how accurate you require it to be. Perhaps the most common use of this saw is to chop steel angle and then to weld it together with a MIG or stick welder that will bridge the gap left by a less than square cut. Because the saw is so easy to adjust the miter to give you a perpendicular cut to the vise, the vertical cutting plane will most often be left as the saw is provided. One of the reasons why this is optional or considered extreme is that the adjuster mechanism is not a part you can make without some machining tools or employing a machine shop. The method I have devised is only one way to accomplish this. You may be able to come up with a simpler idea. Because the saws may vary, especially between brands, it may not be a good product for a CNC shop to produce in volume. The actual turning of the parts is covered in Modifications, Part 2. This is the relationship of the vertical plane shown with the square sitting atop the stock I just cut. Here is a fast way to check your saw. Obviously, cutting actual stock is the best test if the rest of your adjustments are correct, but time-consuming. Note at the end of this side view, you can see the blade touch the bottom of the square because the saw was poorly aligned. This is the prototype bow pivot adjuster. An interesting characteristic of the saw is that the bracket hole on the table base, near what they refer to as the pivot, is actually larger than the hole on the other side. The spring holds it to the front side of the hole. By default, this gives us some leeway to play with the axle shaft on the other end. I do that with an eccentric bushing. The main part of the shaft could be the original shaft with a modification. I made this one from stock. These are the original sketches I made with measurements. Here is an animation of the part modeled in Fusion 360. Note the eccentric action. I didn't want to fight Fusion's drawing module today, so here's a sketch of my final dimensions that fit my particular saw. I determined that to make the hex portion of the bushing 1 1/4 inch instead of 2/10 of an inch makes it considerably easier to adjust. We are going to be working with all of these pieces. There will be detailed instructions, but study the way the parts go together here for a minute or two. In the lower left of the slide is a photo of a correctly adjusted saw. You should note the relationship of the top of the castings. We are going to adjust the verticality of the cut first, but we need to make two preliminary adjustments to the blade guides initially so that the rear bearings do not get in the way and so that there is not a twist in the blade between the two adjusters. You'll need one of these or something similar to it. The hole is just for storing it on a hook. This is one method of installing the blade guide adjuster tool. If you haven't already, remove the upper bearing pivots. The bearings will stay in place but be loose. Remember the picture in the lower left corner back on the parts diagram? The key here is to set the equal length pivot ends flush on the adjuster tool while keeping the outer bearing races above the teeth. Do the other adjuster in a similar fashion. We are doing this temporary adjustment to prevent a twist in the blade between the adjusters during the testing process. We will set them with the top bearings in place in part 4. For some reason, this clip stopped before I removed the shaft, which is just a matter of driving it out from the other side. Oh, here it is from another table I did later. I had test fit everything before this installation process you're going to see here in the next couple of clips. Unfortunately, after I Loctited this bushing into place, I got called away for a few hours, and you'll see when I come back I have some work to do to actually make the adjustment. You should realize that, like a gunsmith that is improving a rifle for competitive shooting, this is not a bolt-in process because the dimensions of every saw are unique when you are chasing accuracy. These parts need to fit snugly, but not too tight. Depending upon the dimensions of your saw, a 1/2 inch and a 5/8 inch ream could come in handy. By changing the geometry here, your saw may use anywhere from 0 to 2 washers behind the pivot arm. may also need a spacer between the pivot arm and the bow. This is to prevent putting a lever force on the pivot shaft. This saw used two 11-gauge spacers. The saw I did after this one required no spacers and no washers. Here's a sloppy video of my plasma table cutting one of the spacers. Here I'm spacing the blade out with 2 layers of duct tape so that the teeth will not hang up on the square during the vertical drop test. The camera angle is not very good here, but you will rapidly be able to determine whether the blade is hitting the square at the top or the bottom of your normal cutting range. This saw had a significant gap at the top of the range of cutting, which required me to turn the eccentric bushing to raise the shaft on the blade end of the shaft. And here's where I came back a few hours later and had to heat up the Loctite so I could actually make the adjustments. The test and adjust process was repeated 3 times on this saw to achieve a satisfactory vertical cutting plane. At this point, I allowed the Loctite to cure. The next 2 pictures are of a 1 5/8 inch 6061 aluminum round chunk I cut before correcting the vertical cut path. I then chucked them in the lathe to see how good the cut was. As you can see from the 10,000th and 15,000th before skim cuts, the vertical cut was off by about 20 thousandths in 1 5/8 inch. This last picture is a 5,000th skim cut on a chunk I cut after correcting the vertical cut path of the saw. Just enough to remove the teeth lines from the bandsaw blade. There is no discernible error in the cut path. Thank you for watching Adjustments Part 3. Please continue on to Part 4, where every saw will benefit.